execute the program. So I will just share the Keel software window. Once the program is ready, yeah, this is a data transference program. Okay, so last week we have written this program to transfer the data from one memory location to another memory location. That is this. Now here I already told you that I think let me load the memory address as this one only. So 4000000 starting address of the memory location. So now here I have to load the value to R0 register. Okay, so here R1 is acting as a pointer register which will point to the memory address. So then I have to load the first data. So it is not only from R1. So instead of that, R1 comma so do I need to add this? So that means R1 plus 1 whatever value is there that will go to R0, but I don't want like that. R1 as well as that is 0th location and first location, whatever the data is there that should be moved, right? So here if I use this, what happens? LDRB lower byte, only lower byte is moved. Okay, so that means the data will be loaded. So lower the 8-bit data will be moved to a lower byte of the register. Okay, so now I don't want that. I want the 16-bit number to be loaded into R0. So how will I do that? So do I need to use LDRB instruction or do I need to use LDR instruction? So can I use LDRH instead of LDRB?
Yes, sir.
Yeah. So because LDRH is going to load the 16-bit data from wherever the memory location is there. Okay, so here instead of LDRB, I have to use LDRH R0 comma. So here you can just give simply R1. Correct. So then I need to use LDRH R2 comma R1 comma hash 2 I have to give, because after 2 memory location I need to have the second number. Okay, so 0 and 1, 0th memory location and first memory location, first 16-bit number will be there. Okay, so that will be loaded to R0. So then LDRH R2 comma R1 comma hash 2. Okay, So then I have to multiply. Straight away I can use mul instruction. So here to multiply, what I will do, MUL R2 comma R1 or no R0 comma R2. So after that move MVN R0 comma R0 comma here R1 hash, instead of this I will give 4. That's all. So let me check whether this program works or not. Okay, so now there is no error. Now I have to run this program. Okay, so now go to debug, memory mapping. I have to include that memory 0x40000000, comma 0x4000ff, read, write, execute, map range, whatever. It did not. Let me see. 0, 0. Yeah, 10 is extra there. Map range. Okay, so now it is mapped. Close. So now already this memory location is open. So 1, 2, I think some problem with the mapping. Let me see. Execute to read, write. Once again I will map it, or else what I will do, just proper light is not mapping. So debug, go to memory map. So now I have to 0x4 000 0000, comma 0x4 000 ff, read, write, execute, map. Okay, so now it is done. So now if I edit, yeah, 1, 2, 3, 4, then 4, 3, 2, 1. So this is the data. Now I will do single step. So R1 is loaded with the memory location. Here you can see. Okay. So then see 3412. I think 3, 4. Yeah. I have to give the number in that order actually. 1, 2, 3, 4 I have given. So it is not 1, 2, 3, 4. So first that is 4000001 is the first data, and then 00 is the second data. Here you can see. Okay, R0 is loaded with that. Understood? So then LDRH 2143. Yeah. So here also same. So that means higher byte is loaded into lower byte is over. So it has been actually exchanged. Okay. So then I will do multiplication. See, R0 is updated with the multiplied value. So I think here it should not be STRB, it should be STR, only STR. Okay, so we'll see what happens. If I give STRB, only the lower byte, I think it may go to memory location. We will see what happens. Yeah, so only the lower byte 49 is loaded into +4. Okay, so here +4 is there. So that is 49 is only 49 is updated there. So therefore now what I will do, instead of that I have to give only str or strw. Str.w we have to give. Okay, so here instead of this str.w or only str, yeah, only str we will instead of 4 I will give 6. So let it be there, some gap should be there. Okay, so I'll run this. What is happening? Someone. Yeah. Now we will do this single stepping. Oh, sorry. So I will just reset this. I have not entered the data here. So this is 3, 4 now. I will enter it from OK. Before that mapping we have to do memory map 0x430 comma 0x430. So read, write, execute, map, close 3, 4 1, 2. So then this should be 4, 3, 2, 1, right? So therefore this should be 4, 3. No, not 4, 2, 1. And then 4, 3. Okay. So now we will see. Now or not. Okay. 1, 2, 3, 4. So then 4, 3, 2, 1 R2. Then after multiplication. So just I think MVN we should not do. It is just complementing it. I think last club we did once complement, right? Yeah, that MVN we should not do. This is once complement. I remember. Run this program. Go to debug, memory mapping 0x4000000, comma 0x4000ff read, write, execute, map, close it. This should be 3, 4 1, 2 2, 1 4, 3. Okay, so then single stepping. So multiplication is done, data is stored. See there, again here also the data is stored, lower byte first, then higher byte last. Okay, understood? Here you can see. So the answer should be 04 C5 F4 B4. That is the answer. Okay, understood? Yes or no? So 1 2 3 4 into 4 3 2 1 we have done. So if you just manually multiply and see whether you are getting the correct answer or not. Understood? Yes or no? At least for this you answer.
Yes, sir. Yeah, now you all of you can execute this program. Then note down the result. So result, how will you note down? So the memory location only you have to note down. So starting memory location, whatever is there. So
ಸರ್ ಈ ಕೋಡ್ ಇನ್ನೊಂದ್ಸತಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀರಾ?
See, this is the starting memory address of my data. Okay, okay, let me keep this in the debugging mode only so that you will understand it properly. Let me map the memory location also. Yeah. Yeah. So now when you go to, let me go to the program. Yeah. See, this is the address, memory address. 400000000 is the memory address where my 16-bit data is present. First 16-bit data. But here in the memory location, you will be having pointer, I don't know, but let me use, what is that? Yeah. Leave it. Now here, can you observe the memory location? Yeah. Can you see the memory location here? All of you can see the memory location.
Yes, sir.
Yeah.
Yes, sir.
So this is the first address of the memory, 400000000. Okay. And in each and every memory location, I can store only 8-bit of data. Only 1 byte of data can be stored. Okay. But in your program, you have to multiply two 16-bit numbers. Two 16-bit numbers. That means 16-bit binary numbers multiplication you have to do. 16-bit means here
whatever the data is there in two memory location, so it is only one data for us. For example, here 4321 I have written. Okay, so 4321 and 1234. So this is the data for me. First number is 4321, second number is 1234. Okay, understood? Yes or no? Now I have to get this data first. In the memory location, data is already there. I have to get that data. To get the data, what I am doing here in the program, in the first program, in the first line of the program, R1 comma hash 0x400000. Starting address of the memory location, I am just loading it into register R1. Okay. So then, 1 second. Hello. ಸರ್ ಇಲ್ಲ ಇಲ್ಲ ನಾನು ಇನ್ನೊಂದು ಲ್ಯಾಬಲ್ಲಿ ಇದ್ದೀನಿ ಸರ್ ನಾನು. ಓಕೆ ಓಕೆ. Yeah. Okay. Here in the second instruction, LDRH, load the half word from the memory location which is pointed by register R1. Load the half word, that is 16-bit data, to register R0 from the memory location where that memory location is pointed by what? Register R1. Okay, understood? So that is how we have got R0 with the lower byte first and then higher byte next. So 4321 we have got 4321. So when I execute this program, this line LDRH R0 comma hash R1, it will go to the memory location where R1 is having the value. It will go to that memory location and load the value. So that is the first value into lower byte and the second value into higher byte in R0. Understood? Yes or no? Still, is there any
Yes, sir.
confusion? Understood, right? Yeah. In the next instruction, now here I have to load the second data, second 16-bit data to another register R2. Okay, so when I execute this instruction, load the half word to register R2 from the memory location which is pointed by this particular address. Okay, so here what is happening, whatever R1 value is there, so that is this value plus 2. Okay, so plus 2 means it goes to here. At last you just have to replace it with 2. It goes to that memory location, that is this one. Okay, so 3 4, and this 3 4 will be loaded into a lower byte of the register R2, and this 1 2 is loaded into higher byte of the register R2. Understood? Yes or no?
Yes, sir.
Okay, so now we have to multiply these two, R0 comma R2, and store the result in R0. So here this is basically destination comma source, so therefore R0 to R2, so it just multiplies and then the result will be stored in R0. Finally we have to store the data, whatever the result is there, so we have to store that data into memory location. So how do I identify the memory location? Here I am going to use the same memory location, okay, plus 6. So that is why, say this is 0 1 2 3 4. Okay, so then 5 6, it will come here and then
store the data from here, from this point forward. Okay, understood? So this is 0, 1, 2, 3. Right? Understood? So now I will execute step by step. See, as I told you, R1 is loaded with a memory location. Okay, so first memory location address. Okay, memory address is loaded with R1. Next, LDRH R0, R1. So 4321. 4321 is loaded to R0. Okay, I told you the first byte will go and sit in the lower byte of the register R0, and the second byte will go and sit in the higher byte of the R0 register. That means not higher. So next higher byte. So this is 21 is lower byte. Next higher byte is 43. Okay. Similarly, when I execute the next instruction, R2 is loaded with this value. So here also it goes to this memory location, that is 40000000 02. It goes to this memory location. This is 02. This is 00, 01, 02, 03. So it goes to 02, and this value will be loaded into lower byte of register R2, and this 12, 1, 2 will be loaded into next higher byte of the register R2. That is done. Okay, so then it has to perform multiplication. So once the multiplication is performed, then the data will be, the multiplied answer will be 04C5 F4B4. That is the answer. Now I have to store this answer into a memory location. So where that memory location should be 6, starting from 6. So here what is happening, lower byte is stored first. So that is what, I think little endian, big endian, all those things we have discussed, right? So the lower byte first goes to what endian is this? Lower byte is going to the lower memory location. So that is little endian. Here it is following little endian. Okay. See, lower byte is first, so then higher byte last. So this is called little endian. If we want big endian, that also can be done. So that means higher byte first, lower byte last. So that also can be done. Okay, so therefore higher byte is 04 C5 F4 P4. Like this only we have to read. This is the final answer. Got it? Any doubts still? See, I told you, I have already explained the logic of the program, but still you did not write the program. See, I also have not written this program. So in front of you only, I sat and wrote the program. This is how you have to learn the subject. Otherwise, you will not come to know in-depth knowledge of each and every controllers. Okay, so you just have to take the reference of the instruction sets. Then you should try to write the program. This is the way you have to write the program. Okay, so till today I also have not written the program for this. Just now only I wrote the program. Whether you believe it or not, I don't know, but that is the fact. Okay. So still, do you have any problem, any doubts? Do you have any doubts? Okay. So let me explain the procedure again, once again. So I think I will just close this project. Okay. So to create the project, I will explain. I'm just explaining the procedure. Go to project.
So click on new MuVision project. Okay, so now here first program, so that is multiplication. I will write. See, so here I have to select the device. Network ಇದೆ ನೋಡಿ. LAN ಇದೆ. Okay, so here I have to select the device 1768. I will select, click on OK. So CMSIS we have to go. I have to select core, then go to device, select startup. Okay, so when you click this startup, system startup for NXP LPC 1700 series, system startup will be loaded into the project. Click on OK. Okay, so if you expand this, here you will get that CMSIS. Okay, no problem, but here into some red mark is there in the device. Okay, so in the device red mark is there, so I think it is these things are not updated. Whatever the .h file 17xx.s and then this .c, all these files are not updated. So that is why what you can do, click on this, right click, update config file. So if you have connected to the internet, automatically see version 0.0.0 is there. So updated version is 2.4.1. So just click on that. So it will automatically update. So here also same. So everything is lower version. So therefore it will show that. Now it is okay. Okay. So now once you have done that, then go to target one. Right click on this, options for target. Click on the options for target. Then target, here you don't have to change anything in the target tab. So already 12 megahertz frequency it has been given. Then go to output tab. So in the output tab you can select, you can just tick create hex file. Okay, only that change you have to do in output tab. Listing tab, I think nothing is there to change. User tab also nothing is there to change. Here also nothing is there to change. ASM nothing is there to change. Linker also nothing is there to change. Debug. Okay, so when you come to debug, so here you have to select basically, so debug here you use something some Cortex debugger or something like that, it is there. Instead of that, since we are not connecting it to any hardware device here, so therefore debugging is not required for me. So I just want a simulator. So therefore I will click on this simulator, use simulator. Okay, so use simulator. So then in the debug tab you just have to, this will be use some debugger will be there, but instead of that I am going to use simulator. So I will just click on that. Then go to utilities. So if you go to utilities, I think nothing is there to change in the utilities. It will keep it as it is, nothing is there. So click on OK. That is about the target options. Okay, so then click on source group one, right click on that, then add new item to group source group one. Click on that. Okay, so then, so here I need to write as ASM file, assembly language programming. So therefore ASM file, and then you have to give the multiply file name, you have to give assembly language program file name, you have to give add. Okay, now the program is added here. Starting with one tab you have to give area, program, comma, code, comma, read only. Okay, so then entry. Okay, so then
export to main. Okay, so then underscore main. So this is starting. So here move r1 comma hash 0x4000000. Then ldrh r0 comma r1 ldrh r2 comma r1 comma hash 2. So then mul r0 comma r2, then str r0 comma r1 comma hash 6 sti no swi ampersand 11 and that's all. Okay, so once you have done this, save this, just build. What error you will get, you just see. No errors. Okay, so no errors, right? So no errors are there here. Then run the program. Okay, so while running the program you may get some problem, so we will see what happens. Okay, so already memory locations, we will go to debug. We have to map the memory 0x40000000 comma 0x4000ff. Read, write, execute, map the range, close. So now I think memory, yeah, to memory window already it is there. So where it went, I think time. Yeah, memory one came. So now here okay, so 43122143 something like that I have given. Single stepping if I do, yeah, so it is going somewhere, so it is not going to execute your program. So therefore now for that what changes you have to make, I will just tell you. You can just note down. Just close this. So this has to be there. You just have to go to devices, click on this startup underscore lpc17xx.s startup. Okay, so then go to line number 121. So line number 121, here you just have to write import underscore main. Already it is there. Okay, import main. So then go to 270, yeah, here. So these two you have to comment, import these two lines you have to comment. Okay, so then build. Okay, so after that run the program. Again you have to map the memory. See, every time when you debug, you just have to remember this to map the memory location. Okay, read, write, execute, map, close. Now I will enter the data into it. 1 2 3 4 3 4 1. Again it is going to that. I think something is missing there. Let me see. Yeah, I think that system init we need to change. Yeah, this one we have to comment. Should not go to system init. Okay, so once we write import underscore underscore main, so then we have to system init is not required, so it will go back to, so we will see what happens now. Still it is going there. Think BLX or not. No. This one is also not. Some these things we are missing, I think. So let me see. I will just open that project and let me see that project. Yeah. So here it is system init only. BLX or not. Yeah, import underscore underscore main I have given in line number 21. So here nothing is there to change. System init is there. When we go to line number 270, 272, 273, we have, yeah, commented. Then why it is not? Yeah, BLX R not means it should go to BLX R not only. Here it is happening, but there it is not happening. Why? Yes. No, it is coming here. Reset. Just a second. Where is PC? It is R15 only, no? CE. Yeah, it is CE. BLX R not. I think some target. Nothing we have changed. Area, program, code, read only, enter, export. Let us see. Open project, multiplication.
Why it is going to this? We have 121 import underscore main system and VLX are not. Well, program counter value is, I think, here wrong value is uploaded in the disassembly. Why program counter value is see here it is not linking properly. You can observe here. So when we come here, LDR R not, just a minute, BLX R not. Okay, so here it is CE only. In the disassembly, you can see the program counter value is CC. So then now it is BLX R not, small R not. It is going to that. Okay, so CE, it should be 105. If it is 105, then it will come back. Otherwise, since it is 11D is loaded, CE. See here, 11C is loaded, so therefore it is going to 11C in the disassembly. LDR almost no change.
Everything is correct only. Text code read only. Why is it going to .c file? I am not understanding. This is C program actually. So it's going to C file. Here it is working, here it is not working. What may be the problem? Import underscore main LDR are not. 121. No. 128 is area text code read only import main. Here also import main system init main. Should work actually. Then when we go to 270, 273, it is commented. Here it is working, but there it is coming to this. In new project, why it is not coming, I am not able to identify. But anyhow, you know the procedure, right? So you came to know how exactly we have to run the program. Go to line number 121, add this, import underscore underscore main, then export reset handler, system unit, import main. Export reset handler, was it there? Or not, comma is equal to main underscore underscore main. And then here 72, 73 is commented. That's all. Only those three changes we have to make. Very simple. So here, if you use something else instead of main, something else if you use, so whatever you use, it's the same thing you have to give here as import in line number 121. Import underscore underscore main, and then here I think something will be there. So here also you have to give that underscore underscore main, or whatever you give there, export. So then come back to these 272, so 273 line, just comment these two. Okay, so then you have to run. But still using compiler v5.06 update 5 build. Is this the problem? Using compiler. RMCC. This is what I will. Here also same, no? Yeah, v5.06. RMCC build. But here export reset handler, it is there.
R0 is loaded with system init. So that system init is value. System init value is how much? Where is this actually defined? Import system init. Let me comment this. What it was. Let's see. Yeah, system init is not. Okay. But basically, what is happening here? That system init also we are importing, overwriting actually. Import here, once we do that, 1 second, I will show you. Not this one. Yeah. Here, so what we are trying to do, so while, see, when I create this project, automatically the system unit will be system initialization. That is the, basically again, we have discussed the interrupt handlers, all those things, right? So system init will also be one of the interrupt handler. What happens? It will reset to some value. Okay, system init will reset to some value. So here, since I am importing this one only, underscore underscore main. So here I am exporting, and here I have to import it in the .s file. So here I am importing it. So again here I am overwriting by with main by system init. So that is why this problem was happened. So now I think in the previous project, system init was set for the particular R0 value. So therefore it used to redirect it to the program itself. Okay, so therefore here we just have to comment that, and ldr r0 comma underscore underscore main only we have to give, so that it will be redirected to the program itself. Okay, understood? So this is the procedure for creating the project, and then before compiling the program, we just have to make these changes. So here again, you can just see here, if the system init is redirecting to the program itself, then no need to commit this. So if it is not redirecting to the program, so then you can commit this and then import main, again ldr r0 comma is equal to underscore underscore main if you give. So then that program, that handler will be redirected to this user. See here in ARM, in 8051 it was not like that, because there we have only one particular this ones, but here we have different modes. So the modes of operations are two here. So one is privileged mode, another one is, that is handler mode, another one is
thread mode. Okay, so thread mode is nothing but the user mode, so where the actual program execution takes place. Okay, so handler mode, it is basically used by the exception handler. Okay, so that is why these confusions are there while executing the program. So that is why you should be very careful while compiling and running the program. Compiling you may get, you may get 0 errors, but while running the program you just follow these procedures so that you will get the proper execution of the program. Otherwise, no. Okay, understood? Yes or no? So I think we could complete only one program today. So I thought of you should write 2 programs and then you should execute both the programs, but it did not happen. So at least the next lab we will try to write 2 more programs and then execute it. Okay, but next lab we don't think I will be helping you. So like today, so next lab you have to write your own program, but I will give you 30 minutes time. Within 30 minutes you should be able to write the program. Okay, understood? Any doubts? Any doubts? Shall I wind up now? Students,
No doubt, sir.
okay. So I have already called your name earlier, so that will be your attendance.